Hello everybody, my name is Elsayed. I am an occupational health consultant and it's a pleasure to be here today to discuss with you an important occupational hazard that you are exposed to during your work in the construction field. This hazard is the ultraviolet radiation. The main reason I chose this topic is the fact that ultraviolet radiation affects nearly every living organism. Whether this effect is useful or harmful depends on its wavelength. It's also considered a major public health concern since overexposure to these radiations can result in many adverse health effects. I hope by the end of my lecture you will know more about the physical criteria and sources of ultraviolet radiations and the health hazards associated with it. I'm also going to discuss about how do we get exposed to these radiations, what is the safe exposure limit, and how can we reduce this exposure. Please feel free to interrupt me if you have any question. So, first of all, what is ultraviolet radiation? Ultraviolet radiation is one of the non-ionizing radiations present in the electromagnetic spectrum. It has a shorter wavelength with higher frequency than visible light, but longer wavelength with lower frequency compared to X-ray. Ultraviolet radiation is broken up into three wavelength ranges. The first one is called ultraviolet A, with wavelength range between 315 up to 400 nanometer. Second, ultraviolet B, with wavelength range between 280 and 315 nanometer. And lastly, ultraviolet C, with wavelength range between 100 up to 280 nanometer. This slide shows the different wavelengths of ultraviolet radiation. You can see here that ultraviolet C, which had the shortest wavelength, is considered the most harmful rays. Ultraviolet B rays are less harmful, but can still cause skin redness, also known as erythema, skin burns, and increased risk of skin cancer with prolonged exposure. And this is because the shorter the wavelength, the more energetic and harmful the radiation is. Luckily, we are protected from ultraviolet C by the ozone layer, and ultraviolet A is the main ray that reaches the Earth's surface. Although it is less harmful compared with ultraviolet B and ultraviolet C, it is very prevalent and can penetrate into the deeper skin layers, connective tissues, and blood vessels, and contributes to the damage that we explain as premature aging. This slide demonstrates how ultraviolet C is mostly prevented from reaching the Earth's surface by the ozone layer, while ultraviolet A is able to penetrate deeper into the skin compared with ultraviolet B. Now let me tell you the sources of ultraviolet radiations around us. Ultraviolet radiations are either emitted from natural or artificial sources, and the sun is considered the main natural source for these radiations. Considerable portion of the sun energy lies in ultraviolet A and ultraviolet B regions. Ultraviolet radiation undergoes significant absorption and scattering by ozone layer, especially ultraviolet C radiation. Here it's crucial to mention how the human activities have led to the release of many chemicals such as chlorofluorocarbons, which resulted in ozone depletion and thus increasing our exposure to these harmful radiations. The artificial sources of ultraviolet radiation include arc welding as shown in the first picture, which mainly emit ultraviolet B, germicidal lamps used to kill bacteria and viruses as shown in the second picture, and tanning beds as shown in the third picture. Other artificial sources are ordinary fluorescent lamps, if improperly used, and ultraviolet radiation used for medical and dental procedures. Now, Let us talk a little about the potential health hazard of ultraviolet radiation. Exposure to small amounts of ultraviolet rays is beneficial for us, as it is important for the synthesis of active vitamin D and is also being used in treatment of some diseases such as psoriasis, rickets, vitiligo, and jaundice. However, prolonged exposure is associated with short and long-term effects on the skin, the eye, and the immune system. These health effects can be enhanced by some chemicals and medications that are sensitive to light, such as some cosmetics and antibiotics. The short-term effects of ultraviolet radiation on the skin include redness, sunburn, and tanning. Skin discoloration is a sign that the damaged skin is trying to protect itself from harm. Long-term effects include the formation of raised-off skin growth known as actinic keratosis, as shown in the first picture. Actinic keratosis is a known risk factor for skin cancer. Premature skin aging, where the skin becomes thicker, wrinkled, and leathery, as shown in the second picture. Other effects include freckles and, most dangerously, skin cancer. The United States Department of Health and WHO have classified ultraviolet radiation as a human carcinogen. It was found that skin cancer affects up to 20% of the American population, and that unprotected exposure to ultraviolet radiation is the most preventable risk factor for skin cancer. Skin cancers are mainly of three types. The most common type is basal cell carcinoma, as shown in the picture. This cancer rarely spread to other body parts. A meta-analysis of 23 studies showed that the outdoor workers have 40% higher risk of basal cell carcinoma. The second type is squamous cell carcinoma, which is considered more dangerous due to its ability to spread all over the body. It usually presents in form of large masses. Similarly to basal cell carcinoma, a meta-analysis of 16 studies found an increased risk of squamous cell carcinoma with occupational ultraviolet radiation exposure. The third and most serious form of skin cancer is malignant melanoma, as it causes more than 75% of skin cancer death. Skin burns from ultraviolet exposure is a main risk factor for this disease. Going to the effect of ultraviolet radiation on the eye, short-term exposure can lead to inflammation of the cornea, known as photokeratitis, or inflammation of conjunctiva, known as conjunctivitis. On the long term, degeneration of the retina and cataract can occur, which may lead to blindness if left untreated. This picture here shows how cataract leads to opacification of the eye lens, thus interfering with vision. Finally, ultraviolet radiation may cause suppression of the immune system that may lead to enhancing the risk of infectious diseases and limiting the efficacy of vaccinations. Now it is important to know who are at risk for this hazard. People who work outdoors, such as construction workers, are the most likely of all workers to suffer from health effects of solar ultraviolet rays. Other workers may be exposed to ultraviolet radiation from other non-solar sources that we mentioned before, including arc welders, food and drink irradiators, dentists and assistants, and laboratory workers. There are some factors that may increase our risk of ultraviolet exposure. First, the sun level. At noon, the sun is highest in the sky, causing the highest level of ultraviolet B exposure. The second factor is the latitude, as ultraviolet radiation are the strongest at the equator. Also, the ultraviolet rays are more intense at higher altitudes. Another factor is the ozone layer that absorbs most of the harmful ultraviolet radiation, which has now become thinner. Thickness of the cloud cover is another factor that may reduce ultraviolet exposure. And finally, the presence of reflection surfaces, such as snow, sand, and water, that reflect most of ultraviolet rays, thus causing higher exposure to ultraviolet radiation. Now I'm getting to the most important part of my talk, which is how to protect ourselves from this hazard and what should we do if we are overexposed. In order to reduce this hazardous exposure to ultraviolet radiation, we can use different mitigation techniques. First, providing shade cover at outdoor working places, trying to avoid outdoor working at the peak ultraviolet radiation time, which mainly between 11 in the morning till 4 in the afternoon, and attempting as much as possible to do the work indoors or in shady areas. If workers must do the outdoor tasks, then rotating workers between indoor and outdoor tasks can reduce total ultraviolet exposure per employee. A very important tool is to provide outdoor workers with personal protective equipment, including protective long sleeve clothing, hats, sunglasses for eye protection, and broad spectrum sunscreen with minimal sun protection factor above 15. What is the safe exposure limit of ultraviolet radiation? Occupational Safety and Health Administration did not determine certain occupational exposure limit to ultraviolet rays. That's why the Ministry of Labor Radiation Protection Service applied the threshold limit value, which is recommended by the American Conference of Government Industrial Hygienists for occupational exposure of ultraviolet radiation. The exposure limit based on the dose of ultraviolet rays that normally do not produce sunburn or eye irritation. The guidelines limit the exposure to 3 millijoules per square centimeter accumulated over an 8-hour period. However, these guidelines do not apply to workers exposed to light-sensitive agents, and there is no lower threshold for induction of chronic effects such as skin cancer. Sometimes we hear on the radio or read in the newspapers about the ultraviolet index as a part of the weather forecast. So, what is ultraviolet index? It is a measure of the intensity of ultraviolet radiation in sunlight that causes reddening of the skin. This slide shows the ultraviolet index scale ranging from 0, no sunlight, till 11 with extreme sunlight, and the proper sun protection actions that should be applied for each level. I will end my talk with what to look for if we suspect overexposure and what should be the first aid to provide. Ultraviolet radiation overexposure should be suspected in cases of sunburn, skin blistering, and sunstroke symptoms such as headache, nausea, vomiting, and dizziness. In any of these situations, first protect the worker's skin from further direct sun exposure, apply cold water to the affected areas, and then seek medical attention. If the eye is affected, place sterile dressing over the eye and seek medical attention. When such incidents of overexposure occur, it is important to identify the causes and adjust work practices or controls to prevent future incidents. I am including here a list of my references for this presentation, so you can read more about this important topic. Thank you all for your attention, and I hope you found this presentation helpful. I'll be happy to answer any questions. And this is my email. Please feel free to send me an email in case you have any questions or need any further materials to better understand this occupational hazard and how to protect ourselves from it. Thank you.